So, today, we're going to talk about something that feels like a fundamental shift in how AI understands the world. We're moving away from just predicting the next word to predicting the next idea. And it's all thanks to a breakthrough called JEPA.
But first, let me ask you something. Have you ever noticed this? You're using some super advanced AI, but it just feels laggy, kind of clunky, especially when it's dealing with video or anything happening in real time. Well, it turns out there's a really specific reason for that, and that's exactly what we're here to unpack.
All right, let's dive right in. First, we'll get a handle on the core prediction problem with AI today. Then, we'll look at the old, clunky word-by-word way, before we see how this new approach, JEPA, just predicts the whole big picture at once. After that, we'll see it in action, break down why it's faster and smarter, and finally, we'll look ahead to what this more abstract future for AI really means.
All right, so to really get where we're headed, you got to understand where we've been. And right now, most AI thinks in a very linear and, honestly, pretty inefficient way.
Okay, so here's the deal with the vast majority of models that handle both images and language. They generate text auto-regressively. Fancy word, but all it means is they build their answer one piece at a time. It predicts the first word, or token, then based on that, it predicts the second, then the third, and on it goes.
And you know, this whole word-by-word thing, it's got some major problems. It's ridiculously expensive to train because the AI burns a ton of energy just trying to get the phrasing perfect, the surface-level stuff, instead of focusing on the actual meaning. This is what creates that lag we were talking about, which makes it terrible for real-time jobs. The AI literally has no idea what the full concept is until it's finished spitting out the entire sentence.
All right, so this is where everything changes. What if instead of predicting all these tiny little linguistic pieces, you could build an AI that just predicts the entire concept all at once?
Well, that's exactly what JEPA does. It stands for Joint Embedding Predictive Architecture. The goal here isn't to predict the next word. The goal is to predict the core meaning of the whole answer in one shot. It does this by predicting something called an embedding. Now, you can just think of an embedding as a mathematical fingerprint for an idea. So it's about predicting the fingerprint of the concept, not the individual letters that spell it out.
This really just nails the difference, doesn't it? On one hand, you've got the old way, which is like you're laying down a path one single stone at a time, focused on every little linguistic feature. But the JEPA way, it's like seeing your destination clear across a canyon and just, boom, building a bridge straight to it. It's a direct leap to the core meaning.
So how does this actually work under the hood? The model takes in an input, say an image and a question, then that big predictor block in the middle makes a guess. But, and this is the magic part, it's not trying to guess the exact words of the answer. Nope. Instead, it predicts the abstract representation, the embedding of that answer. It's aiming for the meaning, not the text itself.
Let's break that down simple as 1, 2, 3. Step 1. The model gobbles up the inputs, the image and the text. Step 2. The predictor takes a leap of faith, jumping straight to the end and guessing the entire meaning of the correct answer. And step 3, it looks at its guess, compares it to the actual meaning, and learns from how far off it was. You see? It's learning in the space of ideas, not in the space of words.
Okay, so that's the theory. But does this whole abstract idea thing actually work in the real world? Let's check out a couple of incredible examples where it's already making waves.
First up, we have VL-JEPA. The VL here stands for Vision Language, and its job is to take this idea-first architecture and apply it to one of the toughest nuts for AI to crack, making sense of language and video streaming at the same time and doing it efficiently. And wow, the results are just amazing. Because it operates in this abstract idea space, a single VL-JEPA model is like a Swiss Army knife. It can generate text, it can classify what's happening in a scene, and it can retrieve specific information, all using the exact same core architecture. It's a true generalist. You don't have to rebuild it for every little thing.
Okay, so now let's take this out of the digital and into the physical world. The next evolution is called VL-JEPA 2, and it uses these exact same principles to give agents, like robots, a much deeper understanding of the world around them so they can actually plan and do stuff.
And here's the really mind-blowing part. VL-JEPA 2 helps robots do complex things like grasping objects and pick-and-place tasks. And get this, it learns all this from just 62 hours of unlabeled video. That's it. That's nothing. It's so good at understanding physical actions that it actually set a new state-of-the-art in predicting what a human will do next. And it can generalize to new places and new objects without needing to be retrained.
Okay, this all sounds pretty revolutionary, right?
But let's get down to brass tacks. What are the real, measurable wins here? What are the tangible benefits of thinking in ideas instead of words?
First up, raw efficiency. Just look at this. In a head-to-head comparison, they pitted a traditional model with 1 billion parameters against VL-JEPA. And the result? VL-JEPA didn't just match it, it delivered stronger performance with only 500 million parameters. That's 50% smaller, yet more powerful. That is insane. It's literally doing more with less.
And this quote from the researchers really gets to the heart of why this works so well. It's basically saying the model isn't getting bogged down by, fluff. The exact words you use, the sentence structure, it learns to ignore all that and just zeroes in on the core meaning that actually matters for the task at hand.
The second huge benefit is speed, and this is especially cool for video. Think about a sports commentator. A traditional AI is like that annoying commentator who never ever stops talking, describing every single tiny movement. But VL-JEPA, it's the good commentator, the one who stays quiet until something important happens and then tells you exactly what you need to know. It just watches the stream of ideas and only generates new text when the meaning of the action actually changes. They call it selective decoding. And the impact of this, it's not small, it's huge. To get the same level of performance when analyzing video, this selective approach needs almost 3 times fewer operations. That is a massive cut in computation and lag, making things like true, real-time AI assistance not just a dream, but a coming reality.
So what's the big takeaway here? Where is all of this heading? Because this isn't just about making a slightly faster model. This is a foundational step toward a whole new class of artificial intelligence.
This kind of architecture, it feels like one of those crucial puzzle pieces we've been looking for. It's what we need to build the AI agents we've all been reading about for years. Agents that can genuinely perceive the world, reason about what they're seeing, and then act on it efficiently.
This just unlocks so much potential. You're talking about real-time analysis of live sports, which leads to more efficient and adaptable robots in factories, which means we can finally have AI assistants that get our intent, not just the literal words we type. At the end of the day, this is a building block for an AI that has a genuine model of how the world actually works.
And that really leaves us with one last kind of powerful question to chew on. We have spent so much time and energy building AI that can finish our sentences. But what happens? What becomes possible when we finally have AI that can finish our thoughts?